Hi, I'm Libby, and this is my final project for the CS50 Introduction to Programming with Python. It is a mini-Sudoku puzzle solver that uses constraint elimination instead of brute force guessing. This is an example of a 6x6 mini-Sudoku puzzle. The goal is to fill in the grid with numbers from 1 to 6, making sure that each row, column, and the 2x3 sub-box contains each number only once. The puzzle is considered solved when all the cells are filled in correctly, like the one on the right. Let me briefly walk through the high-level implementation of this project. First, the puzzle grid is written into a text file, puzzle.txt, where empty cells are represented by zeros. Next, when the Python program is run from the command line, it will import the puzzle file, validate the puzzle grid, transform the grid into an internal data structure, and then solve it. Finally, the program will output the solution status, which states whether the puzzle is solved or not, and it also prints out the resulting puzzle grid. Now I'm at my code space, and let me show you the file contents of the project folder. First, here is the main Python program called project.py. Next, we have a few puzzle files. These ones contain valid puzzle grid, while the others are test files containing invalid grid. And this is the pytest program used for automated testing. Now let me present the solver program. At its core is the puzzle class. This class stores the grid, tracks whether the puzzle is solved, and maintains a list of candidate values for every empty cell. When a puzzle object is initialized, each empty cell is assigned all possible values from 1 to 6, and these are stored in a candidate dictionary keyed by row and column position. The solving algorithm uses a loop that repeatedly scans the grid, and whenever it finds a solved cell, it removes that value from the candidate lists of all related cells in the same row, column, and sub-box. As candidates are removed, some cells are eventually reduced to a single possible value, and when that happens, the solver fills in that value and propagates the constraint again. This loop continues until either the puzzle is completely solved or no further progress can be made. One important design decision here is that this solver is fully deterministic. It does not guess, and it does not use backtracking. That makes the behavior predictable and easy to test, although it also means that some harder puzzles may remain unsolved. Besides the puzzle class, the program has helper functions that are run before solving even begins. First is the import grid function, which reads the command line argument and makes sure that the puzzle file is not empty. Next is the validation function that checks whether the grid on the puzzle file has the correct dimensions and only allowed values. And lastly is the transform function that converts the grid from text into a two-dimensional integer list. To run the solver, I submit this command and the program outputs the status and resulting grid. Thank you for watching.